Lesson 4.5 is on adding and subtracting decimals. You've added and subtracted decimals before. The difference in this section is that we are going to have some negative numbers as well. So the key thing, like you've talked about before, is when you're adding and subtracting decimals, you need to make sure the decimal points are lined up. Your decimal points have to be lined up when you add or subtract. And then we're going to have different types of problems in this section. One type of problem is when the decimals have like signs, which means they have the same sign. In other words, the numbers are all positive or the numbers are all negative. We're going to be working some of the problems more simply that only have two numbers, but this applies also if you had 3 numbers or 5 numbers or 10 numbers, although we won't get that complicated. So the book on page 80 talks about, in the key concept box, if they have the same sign, we can add their absolute values and then use the sign of the add-ins for the sum. Okay? Another way we can do this is just like you did when we added integers. You can say, I'm going to add the numbers and I'm going to keep their sign. Okay? So if you were looking at this first problem that we're doing here, if you just get rid of the decimals, this problem is going to be kind of like that. Only we do have decimals, but it's similar to if we didn't. In other words, this problem is going to be similar to 5 plus 4. Okay? Yes, it's more complicated than just 5 plus 4, but it's the same concept. We're adding those numbers together because they're both positive. So the first thing on this problem, we would want to make sure we line up our decimals anytime we're adding or subtracting. So I lined up my decimal points here. One thing you can do, you don't have to, but you might find it helpful to add a 0 after the 3 so that we have numbers in the hundredths place on both of those before we add them together. With adding, we always start with our smallest place value position. So 0 plus 8 is 8, 3 plus 0 is 3, and 5 plus 4 is 9. So our answer would be 9 and 38 hundredths. That problem that I mentioned that this is similar to, that would be an estimate for us. We could have estimated this to be 5 plus 4, which is 9. Our answer is pretty close to 9, so that's a good thing. Next problem we have here, negative 5 and 14 hundredths plus negative 2 and 7 tenths. This problem would be similar to, this isn't quite an estimate, but this would be similar to negative 5 plus negative 2. An estimate, better estimate might be negative 5 plus negative 3. But anyway, if they have the same signs when we're adding, then you can keep the signs and just add them together. Say if we have 5 negatives and 2 more negatives, we have 7 negatives altogether. Remember, that's different than what we did for multiplying and dividing, okay? So if I'm adding these, you can use absolute values if you want, like the book says, but the other thing is you could just say, I'm going to add these numbers and I'm going to keep their sign. So I'm going to add these two numbers together, and then I just know that my answer has to be negative because I'm adding a bunch of negatives together. So same idea on this problem. We could add a 0 here after the 7. 4 plus 0 is 4. 1 plus 7 is 8. 5 plus 2 is 7. But then we have to remember, since we were adding, that would be negative 7 and 84 hundredths. The next thing we're going to look at is adding decimals with unlike signs. So once again, the book talks about absolute values. We could find the absolute values, subtract the lesser absolute value from the greater absolute value, use the sign of the add-end with the greater absolute value for the sum. Okay, so I'm trying to simplify this a little bit for you. So here's my advice. If we're adding and the signs are different, you can subtract and use the sign of what you have more of. So if we look at this first problem here, we've got negative 6 and 4 tenths plus 8 2/10. So this is similar to what we did back in earlier in the book. It's similar to -6 plus 8. Okay, I know the decimals are there, so it's not just going to be something we can necessarily think in our head. We're going to have to work it out, but that's the kind of the same thought process we want to have here. So on this problem, since we are adding, but since the signs are different, then they're working against each other. We're going to subtract them. We have more that are positives, so we're going to take what we have more of minus what we have less of. So we're going to do, in this case, 8 2/10 minus 6 4/10. To start this out, we would have to borrow. We can't do 2 minus 4, so we'll have to borrow from the 8. And then 12 minus 4 is 8. 7 minus 6 is 1. And that would actually be our answer here. We had more positives, so our answer is going to be a positive number. We have a similar situation. We're adding these numbers. The signs are different, so they're working against each other again. So we're going to subtract. So since in this case we have more negatives, we're going to take the 9.1 minus the 5.73. Okay, we can take what do we have more of minus what do we have less of. Once again, in this case, we actually will for sure need to put the 0 there for subtracting these. When we go to subtract, we can't do 0 minus 3, so we'll have to borrow. 10 minus 3 is 7. We can't do 0 minus 7, so we'll have to borrow again. So 10 minus 7 is 3. Whoops. Bring your decimal point down, and then 8 minus 5 is 3. And then we need to think then at the very end here, which one did we have more of? We had more that were negative, so our answer is going to be negative 3 37/100. Okay, so just showing you a little bit different way maybe than what the book is on some of these problems. Hopefully you find that simpler, but if not, you know, you can look at what the book has is technically correct. It's just, to me, a little bit more complicated looking. If we look at the try these questions, these are pretty straightforward. This first one anyway. We're adding, they have the same sign. We could add some zeros back here, make sure your decimal points are lined up. Okay, and if you're watching this video, it would be a good idea for you to pause the video and try and work the problem out before you just watch what the answer is, obviously. So number 2, we actually have different signs, so we're going to subtract them. In this case, we have more negatives, so we're going to take the 2 minus the 7/10, make that 2.0, and after you subtract, since we're working with adding and subtracting stuff here, we have more negatives, so our answer would be a negative 1 3/10. Number 6, the signs are the same, so we're just going to be adding these together. So make sure you line up your decimal points. We can add some zeros afterwards. And then after we add, we just need to remember that our answer is going to be negative. On number 8, we have different signs, so we're going to take the difference, we're going to subtract. And since we have more positives, we're going to put that number on the top. can add a 0 if you'd like. Would be actually not if you like, you really need to add a 0 on this one. And once we've gotten that, we did have more positives here, so our answer would stay positive. Next thing we're going to look at is subtracting. So just like we did when we had integers and they were subtracting, we can add the opposite or keep, change. 2 sign changes makes it into an addition problem, okay? And then once it's an addition problem, it's just like what we did earlier in this video. So if you look at this example, I know this is worked out in your book, but we're just going to work it out here, and it might look a little bit different. So if we have this, the first thing I'm going to do is I'm going to add the opposite. It's 2 sign changes in the middle of the problem. So we change the subtraction to addition. Opposite of negative 5.7 is a positive 5.7. At that point, it's like what we've already done. We're going to look at these and we're going to say, are they the same signs or are they different signs? And now we're going to know whether we're actually going to be adding or subtracting them. So since these are different signs, we're going to take the difference, we're going to subtract them, and we had more positives, so that actually would be our answer, which again, it's worked out in your book there, but just to make sure you can see the sign changes. Example 2, similar idea. So first of all, since it's a subtraction problem, we can add the opposite or keep, change, 2 sign changes in the middle. At that point, these are now both negative numbers. So if they're the same signs as each other, we're going to add them together. They're working together. And those are all negatives. So it would be negative 8 and 8/100. Example 3, similar situation. They're subtracting. We can add the opposite, make your 2 sign changes. At that point, actually everything is positive. And so it's just like regular adding numbers together. Make sure you line up your decimal points. And that would be it. So if we look at the try these, number 3. To start out with, we can do our add the opposite or keep, change. If you want to use pen or something to mark that, you can. So at this point, these are the same signs as each other, so we're going to add them together. Make sure you line up the decimals. Remember, 7 is the same as 7.0. And they are all negatives. So that would be our answer, negative 13 1/10. Moving on to number 4. Starting out again. We want to make our 2 sign changes here, add the opposite. And really at that point, everything is positive, so it's mainly just lining up your decimal points and adding the numbers. So on number 5, to start out with, if you wanted to, we've been talking about add the opposite. Technically on this one, you have a positive number minus a number that's smaller than it. So you could get by without doing that, but it never hurts. You're not going to get the wrong answer by adding the opposite ever. That one we'd need to put a bunch of zeros after that, and we'd have to do a little bit of borrowing here. before we can actually subtract that. Look at number 7. First thing we probably want to do here is add the opposite, make our 2 sign changes. Since these are different signs now, we're going to subtract them. And we had more positives, so that would be our answer. Another thing we can do in this lesson is evaluate if they tell us the values of the variables. So what we need to do is just substitute. So in this case, we're evaluating A plus B plus C. They could have us evaluate things that have subtraction between them. This one happens to be all addition. So we would substitute in place of the A. In place of the B, you may want to put that as negative 17 in parentheses. And in place of the C. On this problem, it happens to be all adding. Like I said, if it's not adding, if you have any subtractions, you can go ahead and add the opposite on those. At this point, though, since this one is all adding, remember addition is commutative, which means we can change the order. So what you may want to do is look for, if you have anything that's the same sign, you can rearrange it if you want to, if that's helpful to you. Because the idea is like, let's add all our positives together, let's add all our negatives together, and then we'll have kind of the final battle between them to see how it turns out. Okay, so in this case, whether you rearrange those or not, if you don't rearrange them, you can circle them to keep track what you're doing, I guess. Make sure your decimal points are lined up. You can add some zeros here. Okay, and then now we can see, okay, we have some positives, we have some negatives. So they're different signs, we're going to subtract them. And 17 is more than 16 point anything. So that's what needs to be on top here when we subtract. We have to do some borrowing. And then the 0 technically is optional. And thinking back on this, we had more negatives, so our answer would be negative 665 thousandths. So this gives you an idea about how to add and subtract decimals, including ones that have negative numbers. Have a good day.